The physics of skateboarding, dynamics and tricks. Skateboarding, a sport that has evolved from a pastime to a complex athletic discipline, offers a fascinating case study in the application of physical principles. The intricate maneuvers and tricks that skateboarders perform are not just feats of skill and balance, but also practical demonstrations of fundamental physics concepts, including dynamics, forces, motion, and energy transfer. At the heart of skateboarding physics is the concept of dynamics, which involves the study of forces and motion. Newton's laws of motion are particularly relevant here. The first law, often called the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This principle can be seen in skateboarding when the skateboard continues to move due to its inertia, even after the skateboarder stops pushing it. Newton's second law, which states that the force acting on an object is equal to the mass of the object multiplied by its acceleration, F equals ma, is evident in how skateboarders control their speed and direction. By applying a force through their feet, skateboarders can accelerate or decelerate. The mass of the skateboarder and the board itself also plays a crucial role in how these forces translate into movement. The third law, known as the action-reaction principle, states that for every action, there is an equal and opposite reaction. This is observable when a skateboarder performs an ollie, the most fundamental of skateboarding tricks. When the skateboarder jumps and pushes down on the tail of the board, the force exerted on the board, action, is met with an equal and opposite force from the ground, reaction, propelling the skateboard and the rider into the air. The dynamics of turning and carving on a skateboard also involve intricate physics. When a skateboarder leans to one side, they are essentially initiating a centripetal force, causing their path to curve. The wheels of the skateboard provide the necessary frictional force, allowing the rider to maintain their grip on the ground and follow a curved path. The tighter the turn, the greater the centripetal force required, which the skateboarder achieves by leaning further into the turn. Another key aspect of skateboarding physics is energy conservation and transformation. When a skateboarder performs tricks that involve jumps or aerial maneuvers, they are converting kinetic energy, energy of motion, into potential energy, stored energy, and vice versa. For instance, when a skateboarder goes up a ramp, their kinetic energy is converted into potential energy at the highest point of their trajectory. As they descend, this potential energy is converted back into kinetic energy. The ability to manage these energy transformations effectively is crucial for executing tricks successfully and landing safely. Angular momentum also plays a vital role in skateboarding, particularly in tricks that involve rotations, such as kickflips or spins. According to the conservation of angular momentum, if no external torque acts on a system, the total angular momentum of the system remains constant. This principle allows skateboarders to control their spin during a trick. By adjusting their body position and distributing their weight, they can change their moment of inertia, and thus their rotational speed, to complete a trick and land in the correct position. Friction between the skateboard's wheels and the ground is another fundamental force in skateboarding. This force not only enables the skateboard to roll but also allows for tricks like grinding, where the skateboard slides along an edge or rail. The frictional force is influenced by factors such as the roughness of the ground and the hardness of the wheels, which is why skateboarders often choose their wheels based on the type of skating they plan to do. Air resistance, though often negligible compared to other forces at play, can also affect skateboarding, particularly at high speeds or during aerial tricks. The design of the skateboard, the posture of the skateboarder, and the speed can all influence how air resistance impacts the motion of the skateboard. In summary, skateboarding is not just a sport or an art form, it's a complex interplay of physics principles. From the application of Newton's laws to the conservation of energy and momentum, the dynamics of skateboarding provide a compelling illustration of fundamental physics in action. Understanding these principles not only sheds light on the intricacies of this sport, but also enhances the appreciation of the skill and precision involved in executing each maneuver and trick. As skateboarding continues to evolve, so too will the application of these physical concepts, pushing the boundaries of what is possible on a skateboard.